All right, we're moving on to our first session as well. First of all, I would just like to say thanks Steve and Frank for their comments. I think it highlights the importance of some of the things we'll be talking about in the next session. So if everyone will join me in giving them both a hand, that'd be great. So as Frank talked, he talked about some unprecedented growth and challenges we have due to large load centers. And so the increasing numbers that they're joining the bulk power system is certainly something we want to talk about in this next session. So I'd like you to join me in welcoming Katie Rogers, who is the Manager of Reliability Assessments, and Enoch Davies, the Manager of Reliability Modeling at WECC, and they're going to talk us through some of the challenges and opportunities we have in front of us due to large loads. So thank you.
Sorry, don't use microphones a lot. We probably don't even need to be up here. I think Frank did a great job. So thank you so much. We're just kidding. I will just preface this too, that we do an annual data collection every year. We're currently processing the last data collection we got. So a lot of the numbers that we're going to share are from last year's. We'll be coming out with new ones, but unfortunately there's just a little bit of delay. So the numbers are a little bit older and things may have changed from what we're about to share, but we'll do our best. All right, so why are we talking about large loads? Well, one thing that we have seen in our resource adequacy assessments is just purely an increase in demand. And we measure demand in two ways, right? We can look at annual demand and peak demand. And the chart that you're looking at is annual demand. And there's three lines. You can see that it represents the last three sets of data collection that we have, or the last 3 years of assessments. And you can see that over time, as we go from where we are now, those demand growth projections not only are growing as you go out over time, but each year they're getting subsequently higher. And so in our last data collection from 2024, that was published in 2024, was that annual demand from 2025 to 2034 is going to increase by about 20%, and that peak load is going to grow by about 17%. So we can talk about why that is. Sorry, it's way down there. Okay. At the risk of everybody already knowing this, I just want to make sure that we're all starting from the same point of understanding. So when we talk about large loads, what are we actually referring to? So we have sort of medium loads, and those can range from tens of kilowatts to tens of megawatts. And those are going to be things like commercial spaces, arenas, other entertainment type facilities. And then we have large industrial loads, and those are going to be tens of megawatts to hundreds, even thousands of megawatts. And so those are the refining facilities, data centers, manufacturing, those kinds of facilities. Now, again, in the Western Interconnection data that we collected, what we saw, again, last time was that when we asked about well, what constitutes a large load? Everyone's been very reticent to set an actual megawatt threshold because it really depends. So the answers that we got last time was some people would constitute a 1 megawatt facility as a large load, others 40, 75, what have you. And that's because it could be, does it require a dedicated substation or exceed the capacity of a certain sized circuit. So there's lots of actual ways to measure what specifically makes a load a large load. So it's still very kind of soft in what that is. All right. You may be thinking, a lot of these have been around a while. Why are we just now? Why is it an issue now? Why are we talking about it now? And while they have been around, or a lot of them have been, there's been changes. And so one change that we've seen is the facility size. So historically, we may have been talking about facilities that were 1 megawatt to say 400 megawatts. Now, there are some facilities that are over 1,000 megawatts. I think we heard it at another conference last year that I think this was in the East, but they've seen like a 5 gigawatt single facility. And then you end up where someone goes, oh, that's an ideal location. They're going to build transmission, and maybe somebody else comes in with another 5 gigawatt facility. And so that's just crazy size. One of the other big differences is load patterns. They used to be regular. We used to be able to predict them. We could anticipate what we were going to see when we were going to see it. And now that's not really the case. And we've heard that even large loads that are requesting to interconnect, they may be requesting to interconnect under one load profile, but when they actually get to interconnection, they may have different people in the facility that have a completely different load profile than what they had submitted their initial application with. So makes it really hard for us to anticipate what that load profile is actually going to look like. One of the last big differences is just the amount of notice. I think Frank mentioned that there are facilities that can come online within less than 18 months. And so if you need 18 months to build infrastructure, that's just not going to cut it for them. And it's so that time mismatch is just crazy. And we just don't have that ability to anticipate what those needs are, plan appropriately, design, now get the supplies that are needed, and then actually construct the infrastructure that's needed. I'm going to hand it to Enoch to talk about what we did in the West.
Awesome. Yeah. So, I'll jump right in. So, in early 2024, we recognized this as being a emerging issue, and we're like, how can we get our hands around this? So we set up a stakeholder advisory group where we essentially asked for volunteers. We consulted with an organization to help us organize it, ask the right questions. One of the consultants actually had been part of where there's a ton of data centers in Virginia, I think. So he was invaluable for the process. So we collected a group of transmission providers across the West, and we really started asking questions. What are people seeing? What kind of load forecast do you have? We saw some of that data that we got from our data collection that we do typically. We also asked, all right, so are you treating these large loads any differently than you would other interconnection requests? So when you're trying to decide if you can fit this new, load in, what are you doing? What are your best practices to make sure that you're capable of receiving a large amount of load? And I think there's a lot of motivation, because I think there's a lot of money to be made from getting these large loads interconnected. So they really want to make sure that they're able and capable of getting these loads in their systems. And then, obviously the big thing that we were thinking about from a WECC perspective is, and what are our new risks? What challenges are we going to see as a result of these? So we had a questionnaire that we sent out. We asked a couple of big questions, and essentially, what's the size that you're looking at, and what kind of risk? So we got back some information. So as you can see from this, vertically, you can see that's the amount of risk that people see from these large loads. And then on the bottom is the percent, how big of the interconnection queue. In the next slide, I'll break that down a little further. But as you can see, people saw from our 10 survey respondents that data centers are by far and away the biggest risk and largest part of their queue. So that's really where we started focusing our efforts. And I think Frank touched on this, but data centers is kind of encompassing a lot of things. That's AI, that's just holding information. There's lots of things that get lumped into data centers. And then another interesting one, I'm not sure where this is going to go, but you've got the electrolyzers that a lot of risk people saw from those. And I don't know. I don't know what the future of hydrogen is going to look like. But that was another big risk, but very small part of the interconnection queues at the time. And then you can see some of the other ones. One that was a little bit surprising to me was the electric vehicles. We had, over time, we've seen this really evolve, and electric vehicles at one point were going to be so terrifying because we were going to electrify the cross country like semis, and there were going to need to be 5 gigawatt charging stations out in the middle of Wyoming. It seems like that's been less of a concern for people, but it's still it's still out there. It's still on the horizon, but another potential large load. So now if we look at the queue composition, you can see data centers are by far and away the largest amount of load that's out there. So that is, sort of where the focus has been, where it's gone. And, I think there's going to be a lot of interesting opportunities, but it's pretty much everywhere all at once. Everybody's trying to get large loads, data centers integrated into their systems. And it's an interesting time to be part of that environment. And as you can see, there's still electrification. It's a small part. There's mining is surprisingly quite a big one. I think, as was pointed out by Frank, I think, the metals are still highly valuable. So I think that might be part of why the mining is still a big chunk. And then surprisingly also to me, crypto mining is sort of a small part of the queue. And I'm not sure why that is so small. I think maybe part of it could be that much of that happens on distribution system. So it's less involved in the queues. I think I'm turning it back to you.
All right, so we talked about what large loads are, and now to just kind of break down some of what risks that we saw. And I will just again preface this that we did our own study with Elevate Energy Consulting that was focused on the West. NERC has recently also published a paper on risks. There's a lot of overlap. Most of these are going to come from the paper that we did that it really is focused on what we're seeing in the Western interconnection. So not to say this is exhaustive. I'm sure there are other considerations and maybe ones we haven't even started to experience here yet. But one of the big challenges we see is just that ability to forecast demand. For one, there is just a lack of consistent processes or understanding of when large loads should be included in IRPs and planning forecasts. We also know that there are just huge load interconnection queues, and realistically, they're just not all going to come online, right? The owners may be submitting to 3 different queues and end up only building 1 facility. But it's really hard to know what those are going to be ahead of time. And so how do we forecast that appropriately? We also just don't have a ton of information on what their behavior is going to be, how they're going to actually perform and operate. So again, how can we forecast if we don't know what they're going to look like? Electrification is an interesting one because right, you might have fleet charging like Enoch talked about, but electrification may fall under more of the umbrella of an aggregate load that if you have small pieces, it's not going to move the needle. But if we end up with large adoption of similar behavior, that aggregation of those smaller pieces can result in a big movement. But not all of the load forecasts include things like those smaller pieces of electrification. We also have historically had very fixed load profiles. And so we were looking at, maybe a change in magnitude over a certain time period, but now it's not just the magnitude. We don't even know when the load may show up, right? So that fixed load profile is potentially going to be different, and it may be changing daily, seasonally, and we're just not aware of that either. We also don't know if behind the meter is always being accounted for. And then the potential to participate in demand response programs is another thing that we just don't have a big grasp on. This is new data. So that's kind of the one piece I wanted to show. So when we got our data collection this year, the blue bars represent what is included in the load forecast. But then those yellow bars represent speculative loads that are still kind of known that they might be out there and they might come to fruition, but they're not in the load forecast yet. And so you can see as you go out to 2035, those bars just get bigger. That yellow piece gets bigger. So you can see where it makes it really difficult to know how to plan appropriately given that unknown. And then kind of in a similar vein, our ability to model the loads. Oh, I changed mine, but not yours. Okay. So our ability to accurately model the loads, again, we just don't have the data on how they're going to perform, how they're going to operate. So it makes it really difficult for us to simulate them. Our simplified static load models just can't capture all of the unique characteristics that we anticipate that some of these large load facilities are going to have. And then our current models may be underestimating the impacts of ride-through events. We also just have a lack of some models, such as phasor domain transient and electromagnetic transient models. So without these accurate models, it just makes it really hard to simulate any future impacts from these loads.
I guess just one more thing on the model piece. So I'm the manager of reliability modeling at WECC, and we spend a lot of time talking about this. And so far, we've had really good participation from people who have data centers. It seems like they really want to give us data that we can use. Another challenge is asking for it. Like, we don't even know what we need because, you know, as Katie was describing, like, all right, how do you perform? Like, that's not a useful question. They don't know what that means. So you got to really describe what we're looking for. And it's been a challenge. And I think it's an evolution, and you'll hear more about some ongoing activities trying to address that. But it's been exciting to be part of that modeling effort. Yeah, thank you. So we already touched on this a little bit, but you can we put together this just to show how the timelines really are different. And you know, as Katie described, if you're going to try and add a 5 gigawatt load pocket to your system, you're going to need new transmission. And that's, you know, a decade away. Like, and that's probably being optimistic, to be perfectly honest. So if you really, you know, if we really were wanting and able to integrate all of the load that we think might be coming on out there, we're going to have to either do something different, or we're just going to have to wait. And it's an interesting message to try and give some of these folks. And I think that's why, as Frank described, I think several of them are thinking about, all right, well, if you can't support my load today, can you support it in 5 years? And what does that look like? What can I do to get myself from today to 5 years from now? And so maybe I'll co-locate some generation that I really don't want to keep going forever, but it'll get me through the short term. So that's sort of the big thing, is the transmission is very different. And then, you know, as I think Frank talked about this a lot as well, but you can look at all the timing for the various types of generation out there. Energy storage seems like the fastest, and that's a great solution, but you got to have something to feed it, right? Like, there's not a lot of value in energy storage if it's not getting charged. So that's, you know, while it can be put in really quickly or quicker than the others, it still doesn't quite address all the needs. And yeah, and solar's been interesting. We've seen a huge, and we'll talk about this, I'm sure, as we're talking about the IBR risk, but huge increases in the amount of solar that we're seeing on the Western interconnection. And as you can see from that timeline, it can go very quickly. And then you can see, you know, there's just a night and day difference with how quick they can build some of these large loads, demands. So a new data center, and you know, I've heard it as fast as 18 months. So the 2 to 3 years might even be, you know, conservative. But yeah, the electrolysis projects is like I mentioned, it's interesting to me. I'm excited to see what happens with it. But it's a couple or 3 years to build, and then there's new electrolysis manufacturing. So yeah, the timelines are just very, very different. And I think that's going to be a huge challenge for us to navigate as an industry and make sure that we're meeting everybody's needs. So we've got a few major risks that we've sort of already touched on. So we already have resource adequacy risk. I'm sure you've all felt it, seen it. It already exists. This is out in the system today. Now throw, 1,000 megawatts next to it and see how much better it gets. It's not going to get better. So, we're just seeing, those risks already being exacerbated. And that's really just making sure that, you can balance load and generation at all times of the day, through the night. And then, pile on top of that, the variability of, some of like our resources like solar and wind, where it's a little less dispatchable, a little more difficult to know when those are going to be available. And then, as Katie mentioned, we've got the distribution system where there's also electrification going on. I read about it in the news all the time. Hey, we're doing away with natural gas heating. We're going to move to electric heating. Okay, well, where's that generation going to come from? How are we going to meet that increase in load? And then, building electrification, all the things that go with that. So it's another challenge, another thing that makes, the load forecasts increase. And, now we got to be building generation to meet that. And then, the other big part is some of these, it's real dollars to have like a data center go down, and we expect them to probably be running pretty much nonstop. How are we going to meet that, especially as we're seeing some of our, larger units, nuclear is a fine example, sort of being less and less utilized and, out there for the system to be used. So it's a challenge just trying to make sure that we have enough resources, enough generation, enough transmission, everything to meet just the load. And that doesn't even, factor in any other variables that we've got going on, like Frank mentioned, extreme weather and that kind of stuff, which we're just seeing more and more of. And then, so I kind of already touched on this, I guess, but there's more variability and flexibility being needed on the system. I don't know if any of you followed it, but there were several assessments that were done, in maybe the last 5 years. And, everything needs to be renewable, right? Like that's the direction we're going. And so many of these assessments essentially pointed to, we need this new unknown fuel source that is clean and flexible. Still haven't seen it. Maybe it's hydrogen, but that's just, been the message now for a while, that we need something that is, very highly dispatchable, that can, meet variability and, be flexible so that we can use it. So with that, we're thinking there's probably an increased need for reserves. We also have to make sure that we have energy at the right times. And I think that's one of the things that we've been trying to assess at WECC is, all right, so we've got, all these generators out there. Well, solar only works when the sun's up, so you got to take that into account. And wind only works, not on the hottest days of summer. So we got to figure out how to take that into account. And it's just all kind of piling together. And, you have to somehow understand and make sure that you're factoring in how those things all work. And then, pile on top of that. All right, we've got this load. We're not necessarily sure how it's going to work, how often it's going to need to be running, all that kind of stuff. And then we've got ramping. It's been interesting. I've seen several charts of this where people talk about like AI training, and it can almost look like, a square wave. Just it trains for 30 seconds, then it stops training. It trains, stops training, and it pile several of those together. We might have very large power swings. How do we make sure that we have resources and everything online ready to be that responsive to those kind of power fluctuations? And that kind of shows in the next one where we see the fast ramps and spikes that could cause oscillations. And I don't know how much all of you all follow this, but there's several oscillation modes in the Western interconnection. And if you hit one of those modes, you can see oscillations sort of propagate across the Western interconnection, and that can affect, generators. It can affect all sorts of things. And so, if we start seeing things like AI loads doing all this training and bouncing up and down, and that does trigger an oscillation mode, how are we going to do things to make sure we're mitigating that and be aware of it and keep, operators taking care of that kind of stuff. And I think it's back to you. Oh, no. Oh, yeah.
Okay, so now we're just going to talk about kind of what is ongoing right now in this big question mark of large loads. So one big thing that is currently happening is the NERC Large Loads Task Force. I will fully acknowledge on this slide that I sadly put together. It says 2 white papers, and then there are 3 bullets. So I apologize for that. NERC did set out, they said, we're going to publish 2 white papers. And then sort of in response to the 2 white papers, they're planning this reliability guideline. So just a little clarity there. But the first white paper that NERC actually put out this summer was basically what we just went through. How do we capture the characteristics of large loads and the risks that they're posing? And again, that one was North American wide. So you'll see a lot of overlap with the risks that we talked about, and then maybe some additional ones as they include the Eastern Interconnection in Texas. Then there's a second white paper that I think it's pretty much done, just kind of being reviewed right now. And they anticipate publishing that kind of at any point in this last quarter of the year. But that's really to try to determine what are the gaps that exist when you talk about requirements or existing practices and then reliability standards. Do gaps exist? And what do we do with that? And then again, there's that follow-up, the reliability guidelines to just kind of help, where do we go from here? There's also an ESIG Large Loads Task Force. This is, oh yes, thank you. Not exhaustive, but one of the other major efforts. And they set out, rather than to say, hey, we're going to have one big group and we're going to put out 2 papers plus a third. They said, we're going to have 8 project teams that are really going to tackle separate questions. And so then each of these project teams then have their own deliverables. These ones are luckily not numbered. Otherwise, you would notice that there are only 7 bullets under the 8 project teams. And that is because I actually combined 2 of them. So that long one, interconnection process, is one team, and an interconnection performance requirements is another team. So there are 8. I did check. And then...
And I would love to get you all very excited about a NERC alert that has come out very recently. It's got a lot in it. I will warn you, there's a lot of information we're looking for, and NERC's collecting this. So released September 9th. Responses are due in January. And based on the amount of information being requested in this alert, I would start it now. Or maybe 2 weeks ago or a month ago, because it's asking for a lot of information. And we at WECC are really hoping to be able to use some of that information to inform our data collection, because as Katie's mentioned a few times, we do this annual loads and resources data collection. And last year we asked a lot of large load questions. Well, if NERC's getting that information for us, we don't need to ask those questions. So we're trying to make sure we're not asking the same questions, but we are essentially relying on what the NERC alert is requesting so that we can inform our processes. And it's asking things like, hey, you've got a large load queue. Can you give us an idea of what that queue looks like? And, quantities of how much is data center. And they break data center down into AI. Off the top of my head, I can't remember any others, but there's like many categories that they break the large loads down into. And we're really hoping to be able to use that information to inform our modeling efforts so that we can make sure we're, asking the right questions to get the information to get into our models. We're also planning to potentially even do some assessment work on large loads so we can, quantify the risk. So it's not just us standing up here saying there's risk and, wave our hands that trust us, there will be risk. We'd love to put some numbers behind it. And, as Katie pointed out, the positive sequence domain and the EMT model seem like a real gap right now to know, hey, if you have a fault on the system, what's going to happen to these large loads? Are they going to trip? Are they going to ride it out? Are they going to act in ways we don't understand yet? In my mind, I think back to the Blue Cup fire. I think everybody's probably familiar with that. The whole concept of momentary cessation for inverter-based resources. We didn't even know to ask those questions when, I mean, well, we did. It was in the models. We could have populated it, but we didn't. We didn't ask those kind of questions. And I keep thinking there could be something like that in large loads that we'd really like to get out ahead of. So the NERC alert really asks a lot of information. It's very, very detailed, and we're really looking forward to the information that we might gather from that. So yeah, please work internally to make sure that we're, we, WECC and NERC is getting high quality, complete information on the NERC alert.
I'll just say too, I feel like I've also heard people coming out and saying, oh, large loads can be really beneficial to the system as well. But again, because of the things that we talked about, that we don't have the data or the models to even look at this, it makes this really hard. It makes it really hard for us to say one way or the other. So yes, from the assessment side of the house, I would love to have accurate data so that we can really look forward and go, oh, is this a benefit? Is this a good thing? Or how can it be a good thing? How can we, help inform the industry that's building these facilities so that it is a mutually beneficial relationship? I'll say one of the really nice things, we've worked with the Data Center Coalition, and luckily, they also are highly interested in reliability. And so the fact that we're on the same page as far as goals means we have a really great opportunity to work together to keep everybody reliable. But it's going to take some data and some accurate models to be able to do that. All right, I think that's all we have for slides. Does anyone have any questions for Enoch?
Am I on?
Yes.
Yeah. Steve Collins, Pacific Gas and Electric. Thinking a couple ends of the spectrum. One, we just delay a lot of these large loads, or entities put a lot of restrictions on how those come online. And then maybe the other end of the spectrum is they come online and then we just manage it with like SOL methodology, protection right through, just incident response in a real-time setting. Could you speak of, on that continuum where you think most entities are at? Are they looking more for let's restrict and delay and slow down? Or are they, hey, we're going to put these things on and figure out how to manage them in real time as we go with just, localized SOL response and protection right through and things like that? What are you seeing in the industry? I'm asking for maybe a broad brushstroke on that continuum, and maybe it's the wrong continuum. So tell me that if that's true as well.
I can share just a little bit of what I heard. So through the advisory group that we worked with, the thing is that getting large loads on their systems is really good financially for them. And so there is that incentive that they want to make it happen. But at the same time, they don't want to do it in such a way that is really destructive. And so what we heard is that they would love to have consistency in how that's approached so that it isn't a race to the bottom, where people are not saying, whatever it is, I'm just going to interconnect it so that I can get the paycheck and we'll figure it out later. I think we're a little bit in the Wild West, if you will, right now. But I think what I heard was that there's definitely an interest in how can we set some sort of standard so that we aren't doing things haphazardly. I don't know if you have anything to add.
Yeah, I agree. I think today we are probably closer to the end of get them interconnected. We'll figure it out. And I think over time, as the numbers get bigger and bigger, that's not going to be tenable for the long term. So yeah, as Katie was saying, the feedback we've got is, hey, we really need to get some consistency so that everybody's approaching this the same, and it's driving to that reliability mission that I think all of us have. And I don't want to be the one saying I've got bigger, more hurdles for you to get over. So don't go to that, so you just go to your neighbor. Like that's the risk I think people feel like are out there. So yeah, I think today it's more of that. And I think all this ongoing effort and all this work that we sort of talked about at the very end is really driving to that consistent, like, here's the list of things that you need to do to correctly or adequately, interconnect these large loads.
Okay, great. Thanks.
We do have some questions from our online audience. Is WECC planning to adopt the definition posted in the recent NERC alert?
Next question, please. No, just kidding. It's not, man, the whole definition thing, everyone has kind of gone on and round about, I guess. And I think that the concern with adapting a threshold is, if we say it's 75 megawatts, will everyone rush out to build 74.5 megawatt facilities? So, and we do want to recognize, right? If you're going to go to a small town in the middle of nowhere and build what would be a small facility in a big city, that really large is relative to where you're trying to connect and the infrastructure that's needed to support it. So, I won't say no, but also maybe not yes.
And I guess I'll just pile on it. It really depends on what we end up doing with that definition, right? Like if we decide, I don't know, this isn't, going to happen. I'm not predicting anything. But if we decide, hey, we need to register large loads in some way, and there's a threshold out there, and that is the threshold we use, like I think very much we're going to see all right, I'm not going to be that. So just below that. But if we're using it, more of a data collection threshold, which is my world, right? Like I think we probably want a pretty low bar. Like I know for generators, we look for 10 MVA or larger. That's not the NERC standard, right? That's not the requirement, but we're trying to be below that so we understand the risk to the system. And I could see if we're applying, a large load definition, I could see us saying, yeah, we want to see, 5 megawatts or 10 megawatts represented explicitly so that we can get good models for them, adequately represent them. So I could see it. It really depends on how we apply whatever definition. For the, the NERC data, the large load NERC alert, yeah, obviously that's the threshold they decided for collecting information. Is that all that's what we're going to use it for now. I don't know if that's, a long-term forever. This is the only definition.
Okay, this question came from the same asker and I think is related. It says, the megawatt threshold mentioned in WECC's DPM is 5 megawatts for large loads. Is WECC planning to add this value to a formal definition?
I don't know what formal definition means, but we are sticking with that in our data preparation manual. And please come to our technical groups, technical committees. And if you feel like that needs to change, we're happy to entertain that notion, but that's sort of the threshold we've stuck with. And it's been in there for quite a while, actually. So.
Thank you. Did the stakeholder survey identify any specific areas of the grid where queue congestion or growth is particularly concerning?
I think that was a bit beyond what we were trying to get at the time. I mean, our advisory group was just volunteers who are willing to share information, and it was just trying to understand, like, what are we even seeing? I think that's a great next step, is to figure out where that is, what that looks like. But it was sort of outside of the scope of the group that we had.
And I guess I'll pile on. You did see, in the data that Katie shared in that one chart, we did ask people, and you could kind of see where some of the yellow bars were bigger than others. And I think that's probably a pretty good indication of where queues are larger. But yeah, we have not explicitly gone out and said, all right, is your queue 500 deep and how much can you handle? Like, we haven't asked anything like that.
And I'll just plug also the ITCS, the Interregional Transfer Capability Study that we did last year in response to a congressional mandate, and we participated with NERC in the whole ERO to put that together. There's definitely a bigger emphasis on location and can we move what we need to move at the time we need to move it. So those kinds of, while we're not repeating the ITCS, the lessons that we learned from there are being included in future assessments. So that's definitely where we're going, is trying to look at more regionally specific, where it's tight. Do we have transmission adequacy on top of resource adequacy?
That's it for our online questions.
Well done, Enoch.
You too, Katie. Yeah, thanks, everyone.
Thank you. We'll go to break now.